Hi and welcome back for this class 6 of the series of tutorials. During this class we are going to continue what we were doing during class 5. Okay, during class 5, remember we've been working on the density to add some variations in the density, and we started adding some speed emission controller. Okay, so we started to add an emission attribute here, which we call emit, which will help us to control the emission with time and decide that which of the fragment is going to emit for how long. And so far, we only defined the speed as a controller. And right now, during class 6, we are going to add some age and lifespan and also some phasing ratio to be able to emit this density from only some parts of the fragments. So I'm going to first work on the phasing ratio, but before going into the phasing ratio, I need to do some preparation here. In the previous class, I introduced this emit attribute here that was helping us multiply the density that we had originally here, so we don't affect the values immediately to the density. This one is going to be useful for the rest of the network, and we are going to pass this emit attribute to the rest of the network. So to be able to have it available and nicely initialized, I need to separate a few things. So here, okay, we are going to use it into speed. And you see here I was doing the initialization. So I'm going to remove that from here. And I'm going to create an attribute wrangle. And I'm going to do the creation of the emit here. Yes, you could do an attribute create if you want. It doesn't really matter. So I'm going to say emit create. Okay, so I'm creating the emit attribute. It's on the point, it's a float, it's a 1 dimension, and I'm going to initialize it to 1. Okay, so whatever happens here, if we don't have a speed, then the emit attribute should pass and be actually 1. Now we see it here. Okay. Now what we were using the emit for, it was used here to multiply the density. So I'm going to isolate this as well, and I'm going to do an attribute wrangle this time, and I'm going to affect the density with the emit, and I'm going to call that density final. So what's really happening is that I initialize the density here. Okay, I create some emit attribute. Then I do something here that will change the emit attribute. So all this is going to be connected together. And at the end, this emit attribute that has been modified here to be between 0 and 1, 0 meaning off, don't emit, 1 meaning emit. And then I say, well, multiply the density by this emit attribute so that we do emit density where the emit is 1 and we don't emit density where emit is equal to 0. So let's check this is actually working. Here I should have my density. If I deactivate the speed, nothing is happening. Let's check the values here. So if my speed, the length of the velocity is greater than the threshold, you set emit to 1, okay? If it's below the threshold, then I want it to be equal to 0, okay? So before that, I was initializing it to 0, so it was not necessary to set emit to 0, but now it is. And now you see we have a difference here, so that all the fragments that are not moving at all are now all black, which was not the case before. Let me show you. Okay, I remove it, and now I have the fragments there emitting. So I put this back on. Okay. If I don't do the initialization, it's fine because it's going either here or here. So you have either 0 or 1, it's still working, but it's still better to have this just in case later on I don't want to use the speed. And this is the case. I'm going to deactivate the speed to be able to work on the phasing ratio so that I actually see only what the phasing ratio is doing. Okay, so create the emit attribute, set it to 1, then multiply the density by this. And in between, we are going to add some variations. I'm going to move that on. Okay, so little attribute wrangle again, okay. And I'm going to call that phasing ratio. So what phasing ratio? I'm going to reactivate this blast, so I focused only on this fragment here. And then, so you could use this velocity here. Remember that this velocity, the display of this velocity, is not the direction of the velocity, it's actually a trail, so it's the opposite of the direction. If you don't like working this way, what I usually do is I create another visualizer here, which is V, which you can see here. And this one is now not a vector, but it's not a trail, but it's a vector. Okay, you can choose here between vector and trail. I'm sure you know that. Then I'm going to change this to 0.1 just to reduce the size of this. Okay, so what facing ratio? We want the points that are in the front here to not emit. I want emit here equals to 0. And I want the points that are at the back of the fragment to emit the density. Because I want a trail, I don't want anything from the front. Okay, so to do that, the facing ratio is the way to go. And to calculate the facing ratio, I don't know if you know, but you need the dot product. Okay, so let's call that f at dot equals dot. So you have this function in Vex, which is called dot, and calculates the dot product between two vectors. And between what and what? Well, the velocity, and yes, the normal, because we want to calculate the facing ratio of the point according to the velocity. So this is what we have. And now we see that we have a dot product here. The value is here. Now, immediately what I can see that some values are going from -6 to +6. It's okay. We have the information of something which is in front or at the back. Actually, I'm going to look here. I'm going to visualize my dot product instead of the density here. Okay. So we have the information we want. You see, all the points are here, but only the red ones, only the one in front are red and the one in the back are black. So we have the information we want, but still, I would recommend you normalize your values here, just in case you want to multiply your dot product by something to get a proper value. Because if you leave it like this, 6, then what happens is that you use this dot product later, and you multiply with the density, for instance, and then your density gets multiplied by 6 instead of 1. So you have like 6 times as much density as before, and you don't really understand why it's not working. And it's hard to find the origin of the problem. So I recommend to, as much as you can, and if necessary, and if you really want a 6 here, keep it. But I recommend you normalize this. And to normalize it, you go here, normalize. Okay, normalize. Okay, the normals should be normalized, but just in case, just do it. Okay, it doesn't cost much. And now we have a dot product going between -1 and 1. Okay, it's all spread between -1 and 1, and this should be the result for a dot product, a proper dot product, which is normalized. Good. Now it's going between -1 and 1. That means that we have some values going below 0. Okay, so the emit would be negative. Well, for now, I'm not going to touch that. I'm going to leave it this way. There's one thing that really imports me, that really bothers me. It's the fact that it's red in front and black in the back. So I'm going just here to put a minus. And there we go. We have the red in the back and the black in the front, which is what we want. And as I said, now it's going between -1 and 1, and then what I can do here is f at dot equals, and I clump it between 0 and 1. So f at dot, you clump it between 0 and 1. So you say any values that is below 0, okay, set it to 0. So we don't have any negative value here. That's what I want. And well, this I should affect it. I should put it inside the emit, okay. Now this dot product f at dot is set to inside the emission attribute that we set. So then it's used here. Okay. Oh, sorry, I should do a multiply equal. Okay. So if I do an equal, it's going to override the values that I set before. Okay. But if I do a multiply equal, then it's going to multiply the values that I had before. And so here I will show the density again, and the phasing ratio multiplied by f dot is 0. Okay, so emit should be good. So what did I do? What density? Oh yeah, no, sorry, it's there. It's just too small. Maybe not the right fragment. I'm going to change the seed here. Going to change the seed. Global seed. There we go. So we see we have something. Actually, if I remove the randomize and I remove the noise, then we have it working. Maybe the noise is not working properly. Let me deactivate the phasing ratio. We have this. Maybe the noise, I need something a bit smaller. There we go. So we have, yeah, maybe even smaller. 5. All right. And now if I reactivate this phasing ratio, we have something working. And now if I activate the speed, then it should be that when it's static, where it is, at first when it doesn't move, where is it? Come on, show you. Yeah, there it is. So it's black. That's great. And then it starts moving. And then we have the emission working. Is it still in the front? Yes, we should see that only in the front, in the back, sorry. So that's good. So we have our phasing ratio working. All right. So I'm going to reactivate this randomize for the amount of density. And yeah, so far what we did, we separated the emission attribute that is used. This is basically a helper to multiply the density that is here set here at the initial setup. Then in between, we modify the emit attribute. Okay, this is really a parameter, an attribute that we are modifying between 0 and 1 according to different conditions, so speed and phasing ratio. And then we are finally affecting, multiplying the final density. And now, last thing I want to do in this setup is to introduce the age and an emission that is controlled by the age of each fragment. So, I have some problem with the interface. All right, so what I'm going to do now is I'm going to deactivate this, deactivate also the variation that we had per fragment, and I'm going to deactivate the blast. Okay, so I have all my fragments here, and I'm going to come here and introduce, I'll put an attribute wrangle here in between and introduce an age attribute. Okay, so age. How do you compute the age? Well, let's call that age first. It's equal to basically the frame, the current frame, minus the frame when you started, minus the origin. When did we start? If we had the emission, if we had anything of the particles, we would say when you were emitted. But here we don't have any emission, and so what I'm going to use is the impact, the frame of the impact here, which is frame 31. Okay, so I'm going to say here it's at frame minus 31. Okay, I put that into brackets because as you know, we need to divide, I want the age in seconds, and I need to divide by $FPS, because I think $FPS is, let me check that, just f at debug equals $FPS. And yes, 24 frames per second, so that's right. Okay, so now I know I have an age attribute here, okay, which is 0. If I visualize this age, okay, it's 0 at frame 31, and then it starts increasing all the way to the end. You see? Cool. So now we have this this age thing. We need to define some variations for each fragment. We need to say, okay, you will emit for this much amount of time. So I'm going to define a duration. Okay, that would be a duration attribute. It will be in seconds, and it will depend on the age, obviously, and it will be different for each fragment. So, no, sorry, the duration won't depend on the end. The duration of the emission will be different for each fragment. So I can do a random on the ID, because I still have the ID attribute. and this duration is a float. All right, let me check. I have the ID attribute there. Yes, it is. And I want to visualize duration, so I'm going to set it as an attribute, and then we see that we have something different. Now I put duration. Okay. Now we have this this amount per fragment, and if you want to increase it, then you can do 10, and then it will emit for 10 seconds multiplied by this. So I want to emit. I want to give the duration as a parameter, okay, to the user. So I'm going to give that. So I'm going to say float duration equals channel float, okay, and I'm going to set emit duration. It doesn't take space here. You can use underscore, and when you click on it, you see that it will recognize it and put a space into it. All right, so emit duration, and I'm going to put 2 seconds. Okay, so we have now a value of 2 here in the duration, but it's not there in this attribute. You can see it here. So what I can do is I can fit my random. Okay, my random value is between 0 and 1 originally. So I can do the start frame, the source frame range is from 0 to 1, and the destination frame range is 0 to duration. Okay, so I'm actually fitting duration here from 0 to 1 to 0 duration. And because this is constant, you can, I mean, there is a function which is called fit01, which you can use. It's a shortcut for the previous version of the fit that I defined. And now you have duration that should be fitting between this and this, which means that we have now a different duration per fragment. Okay, so all the points with the same ID have the same duration. Have duration here, and you can see it here. Now what I can do is say, okay, you are going to emit. Okay, so again, multiply equal, because we are grabbing the emit from the previous node. By what? We need to think a bit about it. So at the age of 0, you don't want to emit. And at the age of, at the age of 0, you start to emit, you want to emit. And at the age of duration, you don't want to emit anymore. Okay? So when the age is at 0, okay, you will want to emit something. So emit will be 1. And at the age equals duration, okay, so at the end, you want to emit nothing. Okay, so you guess what we're doing? We are going to do a fit here. Okay, so we fit the age. At 0, you emit. At duration, you don't emit anymore. Don't forget the semicolon. And see emit here. So we start at frame 31. And if I go, now you see it's decreasing all the time. Let's actually visualize emit. This is where we are. Now all of them are decreasing with the same speed. Okay, but some of them should get to 0 sooner. Oh no, emit is the same for all of them. Duration, why is that? Because they all have the same age. Why? Yeah, they all have the same age, that's fine, but they should not have the same duration here. So something is wrong. Between age and duration, you go time per point. Okay, if I do just this, just in case. No, it's actually working. F age, oh, because sorry, duration here is constant, it's 2. I should use the F at duration because this is the one which is actually random. And now you have it. Sorry about that. I'm going to clean this up. So it starts with the emit of 1 for everyone, and then slowly, well, some of them are already 0, okay, and some of them are still 1, and they emit, and then they stop. Okay, so I'm going to clean this a bit. I use duration here, the F duration, because I wanted to see it here and be able to debug. But really what you can do is duration, because we have this, we can say that. We can say this, and then we can remove it here, and then it's working. Okay, we don't need this one. It's the same as for the facing ratio. We didn't need the dot. Oh, I forgot to clean that. So float, let me do that. There, and dot here, and should remove this. I forgot to do that. So it was the same as speed. I did that for speed here when I defined the speed as a float. Here I forgot to clean it up before, but this is what you should have, okay? So we don't have the dot as an attribute. When we activate this, we don't have the dot. Same for the speed. And now we have the age, but we don't really need the age as an attribute. Okay, so I'm going to define age like this. And why is it then? It's there. Okay, really what I need is the emit. Okay, emit is the one I want to modify. All the rest are just variables that are supporting this modification here. They are really helping us, but that's it. Okay, so they all have the same duration, though they have a variation here in the durations, which is good. You could also, if you want to do it the same way as particles, you could create also a variance and add this variance to the duration. Okay, so they all have the same duration, but then they would have a variance which is varying. But I'm good with that, so I'm going to keep it this way. Let's check that this is still working. Okay, so it's stopping before, which is good. All right, good. And then what else can I do? Actually, you know what we could do is define a minimum duration and a maximum duration. So I am going to do something a bit different. We are going to call that a vector2. I'm going to call that emit time. Okay, just to check. And then you have the channel U. This is basically giving you a vector. So emit time. You'll see immediately. Let me just finish this, and then we create it. Then you have two values here. All right. So I can say a minimum of 1 and a maximum of 2. And then I have emit time here, which is a vector. So I can copy paste it. And then I can say, use my minimum value, which is .x, and use my maximum value here, which is .y. .y. There we go. If I put 0 here, we have the same as before. Okay. And then here I can do 0.5 to just increase it, or even increase this one a bit. And then you would have some random values between 0, 5, and 2, or between 0 and 2, as we did before. So I'm going to clean this. And how do you clean this? Well, you just delete all the spare parameters. All of them are deleted. I'm going to get rid, actually I prefer this name, so I'm going to do that. And then change this, and then I'm going to get rid of this. And emit duration here. And then you can just click on here. Oh, I forgot something. Emit duration, vector duration. Yeah, bad on me. All right, get back to what we had before. Okay, so emit time. So we need a float duration. We can get rid of this. Emit duration, calling here, emit duration, and then, sorry, I can do it this way, and then I need to do a float, just saving a few times, there we go. Okay. Cool. This is working, and I guess this finishes this lesson. So we are going to check that all of them together, it's still working. So I'm coming here, activating the randomize, activating the density noise, activating the speed, and activating the phasing ratio. Okay. I realize that maybe the noise is not really seen there. Why don't I see my noise? Noise, density, maybe it's too... Okay, what's happening? Density final is multiplied by the emit. Oh, emit is 1. Noise. And the randomize is not really working here. Why is that? Let's look at the density. The density is between 0 and 1, so that's good. Why is it not displayed correctly? visualize. Oh, sorry. Density. It's time for me to take a break. Randomize. It's working. Noise. It's working. Maybe it's too small. Increasing this. Nah, better. And then here we have the speed, and then we have the phasing ratio, and now we have the age. So that's what we have at first. Okay, everyone is emitting from the back. And then slowly it disappears. Maybe I want to start to emit for a longer duration here. There we go. Then we have the speed. We should be good here. All right, we should have this. So same as before, I'm going to plug this to this rasterize here. I'm going to rewind my timeline, set into the camera, up, and now I'm going to do a flipbook. So we can see here that the emission is a bit more controlled. We stop emitting after some point, after some duration. We might not see much the variation of the noise because of the resolution of first the emitter, and second the pyro object that we are simulating now. But we know it's working because we've seen that on the emitter. Okay, so that's it. If we go back here, we've done the speed, the phasing ratio, and the age. I think for now it's fine. We also have the density noise and the randomized per fragment. Okay, so I'm going to plug this back here. I'm going to cache that again, and I'm going to clean up a bit the file. Well, this concludes this class about adding some variations into the emission of the volume sourcing. During the last two classes, what we've done is really build our own pyro source with some attribute interpolation here. So we define the points, and then we are moving them according to the animation, so that we are saving some time here. We are not scattering every frame new points, but we use the attribute interpolate to be able to transfer the attributes from the original animation onto the points. And then once we had this, we defined some density. We randomized it per fragment thanks to the ID attribute that we created here. And then further down, we added some noise to it. And finally, we controlled the actual emission of this density we created here with an emit attribute, okay, that we created. This emit attribute was passed through all the network here, and every time it was multiplied by some value, depending on the speed, on the phasing ratio, or on the age. And finally, this emit controller, this emit attribute controller, multiplies the final density so that the initial density that we created here is modulated by this emit attribute. Okay, and finally we rasterize everything, and this we've done it already. So we rasterize the density and the velocity, and we cache this so that we can use that into the final simulation here. Okay, good. So this is it for class 6, and I say goodbye, and I see you in a bit for class 7. Goodbye.